Hello and welcome to webinar arranged by StruEngineers. Good afternoon to all of you, or good morning, where are you located? It all depends. And then we are talking about cost-effective and time-saving way of construction and adopting the precast technology. So, talking a little bit about StruEngineers. Basically, we are a company owned by StruSoft, which is located in Sweden, and we have a background of a company called Skanska with 35 years of experience in making software consulting and many aspects of looking at precast projects. So we are little different company, StruEngineers, because we are producer of software, user of software, and also good knowledge about precast technology. So we have different offices. Typically, our services ranges from feasibility study, concept design to the support to the production and the factories, and all the design supports including it. Why Truesoft or why StruEngineers? Basically, as I said, our origin is Skanska because these software solutions were used in Skanska and the technology is coming from there. StruSoft is basically a spin-off from Skanska. So all the experience of our projects or consulting is coming with software. Then we are really unique company because we have all kind of dedicated experience in terms of precast technology and the skills and experience. We have expert teams in our teams who are really capable of supporting your factory operations, your concept studies, feasibility, and all sort of technical things which are coming with precast technology. So today it is where we are going to showcase like our strengths and our consulting in precast technology. So at the end, it would be like some takeaway where we would be talking to one-to-one if you're really feeling feel that okay, precast could be a technology for your projects, and we would really like to help you with that. Unmuted. Sandeep, can you hear me?
Yes, sir. I am able to hear you.
Okay, perfect. So I hope all participants can hear me. Sorry for this technical glitch. So yeah, maybe next slide, Sandeep. So today we are joined by two of my colleagues, Mr. Paul Tate from UK. He's sitting in our UK office, and Mr. Sandeep Sharma, he is sitting in our India office. Paul has 20 years of experience in precast construction plants and machinery, and even Sandeep has 10 years of experience right from plants to executing the project. Myself, Suhas Moore, I'm also having experience of 20 years with designing and value engineering, specifically for precast projects. So we have real good knowledge today with us. They are exhibiting their skills during this webinar. So if we look at today's agenda, Sandeep, can you flip the slide? Basically, we are going to talk about introduction of precast technology for people who are not having real precast backgrounds.
Sir, there is some technical issue of audio. We're just taking a pause of 2 minutes, then you can start it.
Yeah. Okay.
It's fine my end actually, so I can hear you loud and clear.
Okay.
Good afternoon, everybody in India. Welcome from the UK. Hope you're all well.
Can you participants, can you raise your hands or put some message on chat box if you can really hear us? You can type in message on the chat box if you could hear us. Yeah.
Okay, sir. Now you can start it again.
From the beginning.
No, from here only, I think.
Yeah, okay. Sorry for this technical pause. Basically, the agenda for today's session is to speak about precast technology. We'll be talking a little bit about precast and its comparison with other conventional methods. But we'll not talk a lot about that. Our main focus would be to talk about the wise investment on the precast construction. Then we'll be showing some case studies and our expertise serving these sectors. And then it would be like a question and answer session at the end. We would be really looking forward to get some questions from your side, but not limited to webinar. You can always contact us with respect to your inquiries, and we are really glad to hear. So total duration for webinar would be 1 hour, but if there are many questions, it could extend by 5-10 minutes or so. But yeah, I think this is what we are going to cover today. Sandeep, if we can come to the next slide. So I'm just handing it over to Sandeep, our first presenter. So you can look at his information on this presented slide. Sandeep, you can start your presentation. Thank you.
Hi, good afternoon to all of you. I hope everybody is able to hear me loud and clear. A brief about me, you can all read on this slide. I have around 11 years of experience of precast construction, out of which 8 years of selling precast equipment and machinery. And then I got a opportunity to be on client side. I was heading a company where we got a project to construct 33 tower of G plus 4 story building completely in precast. And now I am working as a general manager sales and marketing with StruSoft and StruEngineers, where our main business is BIM, precast consulting, design, and software. So before I just start my presentation, I would like to show a small video to all of you. Uh, we all know that a house is a dream for all of us and need of basic need. But what kind of house we are looking? Do we want to stay in these kind of houses? This is a video done by Aaj Tak, and in this video you can see these quality of houses in DDA. People are paying a huge money, almost complete saving of their entire life. They make a single house in, but in conventional, out of some years, people get these kind of complaints. You can see very poor quality, lots of damages, seepage, cracks are developing. So this is a very big report available on YouTube. So we do not want to defame anybody, but the purpose is like this is very much available problem in almost every household projects. So yes, now we continue what today we are dealing with. In India, we have lots of problem in real estate market, especially in conventional way. Nowadays, you must have seen that almost every project is getting delay. There are a lot of reasons. There is not just we can say, but you must have seen that due to this corona, uh, people are not available at site, and it is irony of our country that we are a country of a population of 1.3 billion people, and we are not able to get good skilled manpower at the site. We just talk about conventional construction has high maintenance cost. In this video, I need not to explain anything. Also, at the construction site, you can see lots of wastage, pilferage, theft. So we are dealing with all these kind of problems at on each and every sites. So how we should get rid out of all these issues? Uh, in India, we just have seen these kind of images or these kind of seen on each and every construction site. You can find lots of scaffolding, a lot of people are working at the sites. So we have mass housing projects. We require a lot of housing projects to construct, but how to deal with it? If we are going with the same pace, with same scenario, it will take, like, I would say, like decades to construct the uh, construction projects. But by the time we will be able to complete those projects, we will have a new shortage requirement of the houses. So we are going to talk today precast technology, which is one of the uh, finest solution for these kind of problems, because we are not dealing with any special kind of material. We will be just doing precast concrete technology. So we'll be using concrete raw material, so concrete and steel as a raw material, and with the precast we get a better quality in a small span of time. Yeah, before we talk about precast, we just get a brief history of precast construction in India. Yes, we can just bifurcate our history with the three stages. If anybody of you have visited or not visited, I will request you to visit Qutub Minar. There is a courtyard in the entry side. You can see a lot of precast column, precast beam, and precast slab in this courtyard. You can see the extreme left images, and the construction joints are very well very nicely done. These are very much same what kind of construction joints we are dealing today. Yeah, so if we talk about our just pre-freedom time, in 1950, Russia had gifted a precast plant to our first Prime Minister, Mr. Jawaharlal Nehru, which is still very well uh, installed and producing some of the precast elements, which is established in Jangpura area, New Delhi. And now it is owned by the company called Hindustan Prefab Limited. So Hindustan Prefab Limited had constructed many precast buildings in New Delhi. One of them is Oberoi Hotel. Some of the DDA buildings were done at that time. And also Russia was involved in setting up this sale plant in Bhilai, and they did a housing project for their people to stay in Bhilai area. And those buildings are still standing sound in Bhilai, which is called nowadays as a Russian complex. Anybody of you can visit those places, and this is like now a market complex. If we talk about the current modern age, company called Hindustan Battery Limited, they had set up a first hollow core slab production unit in Andhra Pradesh in 2008, and this plant is still producing a lot of hollow core slabs. So what is precast construction? Precast is not a rocket science. It is just a technology where we have a offsite or factory made products. If we differentiate or if we make a stage wise construction, so we make a design in precast is very critical. 75% of our work is in the design and planning phase. So we should have a good involvement or early involvement of all the consultant like architect, structural designer, MEP, HVAC, and all other consultant in a planning and design phase itself. Because once in a precast, if you have frozen your design, then once you started production, then you cannot make any changes. Yes, so we do design with a different consultant at the different locations. No, normally in conventional also we have this design phase is similar. Then we produce precast element based on our production drawing, which are released by structural consultant. So we make all precast element like column, beams, slabs, stairs, which is required to make any kind of building in a factory on environment. Then these elements are properly cured. There are different methods available for curing. It is maybe steam curing or general, like under the sun we just sprinkle water, and then we put these elements as stockyard. Once we get a desired strength, usually we use high strength concrete in our precast construction, so we get early strength. So we transport these elements in a special vehicles at the site, and at the site with the help of cranes, hydra, mobile cranes, we install these precast elements, which is like very faster way of constructing. And once these elements are installed properly, we start finishing of this project. The beauty of precast construction is there is no wastage, there is no debris lying at the site. This is very neat and clean construction sites. So once you have installed the precast element for first ground and you go on second floor, you can start finishing work at the ground floor very immediately. And once these buildings are completed, like all the finishing is done, one cannot really differentiate whether it was done with a precast or it was done with conventional. Now we'll just come to some of the advantage of precast construction. We do not use any brick. Most of these uh, buildings are done with RCC, load bearing walls or column beams. So brick is the main culprit of getting project delay. Like in conventional also, people get frame structure very easily, column beam and slab, and then when they are doing brick, after that they have to do plaster. It is like delay the projects. And using precast, somehow we are helping our mother nature, because we are not disturbing the fertile layer of our agricultural land. So and also it helps not to create any kind of a seepage and other things. When we are using pre-stressed concrete, we do not use reinforced concrete as such. We use pre-stressed tandems or pre-stressed wires. The tensile strength of these pre-stressed wires is very much high if we compare with our normal TMT bars. So that is how we are saving almost 20 to 25% of steel also. And if today we just see any project, steel and cement are soaring, prices are soaring high, and if today we start the project, maybe by the end of the project the raw material cost will be almost 1.5 times. So implementing precast really can cut down the construction time, and it will indirectly saving your raw material cost also. Precast, as we just discussed, that we do all the curing, all the production, these elements are done in factory environment. So these are much easily to install. We do not require much scaffolding. Transportation to erection, we just require a crane. So with the help of crane and skilled people, we can very easily have a safer and better construction sites. We get a very better quality if we compare with conventional buildings, especially in area where we have a extreme temperature. Like if, for example, if we talk about north of India and Delhi, we got temperature from 0 to 50 degree. So due to this process, concrete get contraction and expansion property, and plaster start falling after every like 2-3 years. So with the precast, when we are using these kind of uh, RCC walls, we do not require any plaster, and the quality, because these products are factory made, so you cannot compare with somebody. Like if at any site we have 1,000 people, it is very difficult to supervise workmanship of each and every individual. So quality is way higher, better than conventional. And we do not require any kind of water wastage in a curing process at sites, because all of the elements are properly cured at the factory environment itself. Yes, because these elements are factory made, these are cured properly, so we do not require, there is a very less chances of seepage and maintenance at the construction like buildings. In Europe, they have almost 6 months of heavy snow on their roof and all the way, and they do not get any seepage because most of the buildings are done in precast. In any building, there are very less number of joints in precast. While if we compare with any brick wall, there is almost 500 bricks used in any wall, and then there are number of joints are more in a brick wall. So there are less chances of seepage, and there is which resulting in a low maintenance. Yes, the very easily construction joints can be done. We require a very precise and skilled thing when we are designing these construction joints. But nowadays, lots of consultants are available who design precast buildings. When we are making architectural layout, and we have a limitation that we cannot have a larger span. So somehow we have to introduce lots of column and beam in the building, which somehow does not suit very kind of aesthetic design. And especially like if you have going for multi-level car park, you are going for any high like IIT buildings, hotel, where you require longer span. So either you have to use very thick slabs or other things. So in precast, you can make a very beautiful building aesthetically and structurally very sound buildings. We already discussed we do not use any brick and plaster. So this slide will give you information about what all kind of precast element we require. When we are making any building, whether it's a villa or it's a IIT building, we require 5-6 basic elements, which are column, beam, slab, walls, stairs, internal walls. So we can make all these elements in a precast factory made products. In this building, you can see these colored facade walls. So nowadays, there is a possibility you can make colored facade walls. You can make even graphic concrete. With the help of graphic concrete, uh, you can put your own picture or special logo, anything on concrete, which is like long lasting. Which is in conventional buildings, you have to make paint a building after every 3-4 years. But with this help of color concrete or graphic concrete, these will be long lasting. Then we have a gravity load bearing walls. Mostly in residential building up to 15-story building, we do not require any kind of column and beams. Yes, if they require, we can introduce small column and beams, but mostly these load bearing walls can take care of gravitational and lateral forces. We also have a hollow core slab, which can give you long span up to 15-meter, 20-meter in any buildings. It is hollow and we use pre-stressed wires, so it is very beautiful product. But mostly in residential building where we do not require a span more than 4 meter, then we can use half slab, which are like we can say reinforced room size slabs. And we can also make stairs in precast, lift shaft also in precast, and then internal walls can be done brick, block, and again in precast also. So these are some of the precast elements. Sandwich panel, normally not very much famous in India, but in Gulf and European area where the atmosphere is very harsh, they use sandwich panel as an external element. So it avoid external temperature or external weather to affect our room temperature. Then we have cladding panels, solid precast walls, solid slabs. This is like room size slab. We can make a partition wall out of precast. And for to make hollow core, we have different technology. It's extrusion or slip forming technology. With the slip former, you can make half slab, rib slab, and also T-beams. We just discussed some of the advantages of precast construction. I'll just need not to explain, but yes, it is faster. We cannot say 2 times, it can be 3 times also, depend on your production facility and also at the erection team. Precast save a lot of labor. Usually at any construction site you go, you found thousands of people are working there, and then it is very difficult to manage these people. workmanship. In precast, we drastically reduce labor or involvement at the site. Payback period is very less if you completely like wisely invest and then optimize your production things, efficiently use all the machinery, then your payback can be 3 years also. We have done one project, we'll just come on to this thing. We if we use hollow slab pre-stressed concrete, then we can reduce raw material also up to like 10 to 15%, or yes, if the design is very much efficient, then it can go up to 25% also. Life of these buildings are much higher because concrete is only one product which get more strength as it get older if it is properly cured. So life of these buildings is much higher. And then if we compare it with the Maiwan, or nowadays lots of people are doing with shuttering uh, so these like good company from this shuttering, they give a guarantee that okay, we can give 300 repetition with these shutterings. But with precast, these molds are made of MS or good steel, so you just need to change your shuttering and you can use 5,000 plus 6,000 plus times of these tables. And with the Maivan again, when you have a new project, you have to have a new set of shuttering, while in precast you can like any kind, with the same factory, same mold, you can make any kind of buildings. We come to a short analysis of precast. We just talk a lot of beautiful thing, a lot of good thing about precast, but yes, everything is not as rosy as it looks like. We just talk about strength, speed, quality, economize. We just talk about all these things. Yes, then why, if everything is so good, why it is not getting that much popularity? Yeah, I would say that there is a awareness. People are not that much aware how to do these buildings, how to get precast implemented economically. There are a lot of myth in the general people that precast buildings are not strong, and also a lot of we require a lot of skill and a lot of knowledge in terms of our architect, engineers, and some institutes need to uh, get the precast construction modules in their syllabus. So the major issue is with the weakness, because precast is not that much new and it is very well implemented globally. We have a lot of examples from US, Gulf, and Europe. So if they are able to do it properly, then why we cannot? So majorly we just need to have a good examples and awareness. If we talk about opportunities, we are a country of 1.3 billion people, and lots of people are living without home, and like government is also giving free houses or housing for all scheme. So as per current census, we have a shortage of millions houses, and that is how there is a very good business idea for making these houses. We have a shortage of skilled labor, and there are a lot of other problems which make us to go for mechanization. Like there are some threat also. Government support is always required to make a changes any industry, especially in terms of taxation. Earlier, VAT and excise was a big problem. GST has given some sort of relief, but government should give some relief in terms of custom duty also, because precast is not that much Indianized. Precast equipments are not that much Indianized, so equipments are being imported. There are some bad experience, like I would say that first wave of precast construction, people made wrong decisions, and there are a lot of bad examples. So lots of issue related to that, and a lot of people have their interest why they are not going for technology. The biggest thing is lack of standardization. Precast get better economically if we have more standard building, if there is more repetition there so these all things need to be like taken care of. The major challenges of today's scenario when we are talking about precast construction is understanding the project. See, it's not like construction, like conventional construction, that every project is very unique. So you cannot fix the same formula for each building. We need to pay well to the consultant. We need to have a good people around us. So it is very essential to understand your project and accordingly you implement it. You can make any kind of building in a precast, but the key is to make it economically. We have to make precast affordable. Only then this market is going to increase in future. While we are making investment in precast plant, we should have a wise decision making team with us or good consulting team with us, so that they make a proper balance of your initial or capital investment and the operation. You should have a good amount for the operations also. I have seen some of the company, they made hundreds of crore rupee investment in the precast plant, and later they had not even lakh rupees for like buying cements or paying salaries. So we have to understand all these things. There should be proper demand of this precast housing, so all the stakeholders should come together and they should take a wise decisions. All the consultants should be able to make a good precast friendly layouts, and then once we have a good examples, then obviously awareness will be there in the developers and builders. If we see journey of precast construction in today's scenario, as we said that in 2008 there was a first precast plant in India. It was centralized, established, and if we talk today to 2020, we have almost 62 centralized precast plant. When we say centralized precast plant, we are talking about a big investment and big factories. Though there are a lot of site-based precast plant, if we add those precast plant also, then I would say that there are more than 200 precast factory, small and big, and a lot of thousands of precast projects have been already done in. And here we are talking purely about building sector, because in infra we are using precast almost last 20-30 years. We are making metro bridges. So if we can make those kind of heavy references, then buildings is just very simple and doing. So we just show some of the references which are already done in India. Extreme left, we have a DDA project. They did already like 1 lakh houses units from G+5 to G+20 story building, and they did in 10 years. So average they are making 10,000 housing units every year. The project is in Delhi. If somebody want, we can arrange a site visit for them. Then all of them, these references in the slide are residential buildings. In Noida, a company called Amrapali, they did G plus up to G+33 story building in precast, but this G+22 is completely precast, and when they did G+33, it was a hybrid structure. They use conventional like cast in situ column, and these all curtain walls are precast, hollow core slabs, and pre-stressed beams. This is very good example of precast construction, G+5 and G+9 story building in Sonipat, Delhi NCR region, seismic zone 4. Recently they did 5 lakh square feet construction, and the structure was ready in 6 months time only. So you can, and they have not painted any building. You can see the very aesthetic and very beautiful building. One want to see, we can like make arrangement. This is another one unique project in Delhi NCR region, again in Manesar area. It is Nestle R&D center. Span of the slab was around 12 meter and loading was 15 kilonewton, and the structure again was ready in 9 months time only. Again a good project, white concrete. You can see over here, this is like white facade, there is no paint, and it is like 250 bed hospital. All the precast element were transported from 350-kilometer distance, and still it was viable. So that is why we need to understand our project very wisely. These are some another very good examples. A 10-story commercial project in Pune, in Cadbury building in Hyderabad. Extreme right, you can see 7-story residential building from Bangalore, 10-story multi-level car park at Pune, and on the extreme right you can see 4-story multi-level car park in Mumbai. It's like just front of Mumbai airport. It's a 16-story hotel building in Chennai. You can make any kind of industrial building with precast. You can see here in column, beam, and then hollow core slab is being used as a roof and also side walls. This is another very nice project which is being developed in Hyderabad. It is 26-story commercial building, and the project is completed under like at least the structure is constructed under 1 year time. Very nice project. You can make any kind of commercial malls. You can make these like IT buildings, showrooms, anything in the precast. So here you can see basically you can make any kind of building with the precast, and all of these examples are from India in itself. Like we are not talking about Gulf or Europe. So planning of precast construction is very, very important. So as we just discussed, the design and planning is the key. 75% of your work is done once you are done a smart planning. So when we are doing, first we start with the precast investment to make a precast facility. We need to understand that we have a we are not like kind of European country where like they really require a very automatic plant. So we need to make a very good mix, whether when we are making investment it should not be that much automatic, and we should be not compelled to compromise the quality. So we should consider our ROI and investment cost, because all the investment cost is going to be your utilized on the project itself. So the your technology cost should not be that much high, that so that you are not able to get any project. Nowadays a lot of vendors are available who are making accessories and a lot of precast connections. Earlier all of them were imported from like Finland or other European countries. So we need to make a smart decision onto these things also. Very key thing is that one right person should be on the particular position. Especially usually what when investor he consider that either he will put his conventional team or some of the relative at the position, and yes, definitely we can train easily conventional team into precast, but yes, the training is required. So one should have a right person for the right job. As we just discussed, that all the stakeholders should come together and they should discuss before design phase, because once the design is frozen, there is no much better flexibility to change the design and all the production, because once model is done, then we just going for production and erection. Yeah, we can help you in all this process. The biggest myth is that precast, when we are talking about investment precast, that we are talking about crores of rupees. But there are a lot of people who are not that much big player and they can afford like 50 crore rupee, 20 crore rupee investment in precast plant. So even if you are making 250 unit, like 500 square feet, so we can help you to set up these kind of site-based precast plant in an investment of 1 crore rupee only. So you already have a lot of things out your site, and this additional 1 crore rupee to in your molds, and then you are ready to go for precast construction. Similarly, if we go on a like larger scale, and somebody who make a 5 lakh square feet built up area every year, so he would require a investment lesser than 2 crore rupees. And yes, we are saying that these are not very much automatic plant, but you can get a good quality, you can get all the advantage of precast construction. So we can help you to understand the whether you should go for centralized precast plant or site-based plant is better for your project, whether one should go for complete automation or indigenous process. We can help you to hire competent resources, and or whether you should train your fresher team. We can also help you to get an answer whether you should outsource like other services, or you should go for in-house team. So we can help you to understand what kind of investment you should make, and then you should implement precast very economically. The economically is like the key. Currently, we are already doing 4, 5, 6 projects. We are giving our consulting services for precast. As we discussed, we have other departments also, but precast consult is one of them. We are doing a very big project, million square feet residential project in Africa, where we are helping them to understand precast, implementing from like we are helping them to set up their factory and designing these buildings. We have also implemented our software to like track and monitor precast activity. So this project is under design phase as of now. We are doing a very good project, 5 lakh square feet built up area, affordable housing project. I'll just come on to the case study of this project. We are also consulting a precast factory setup in Pakistan. We are designing their buildings, and right now the foundation is under process. We have 2 clients from Andhra Pradesh, because there is a lot of things are happening after a split of Andhra Pradesh and Telangana. So the 2 customers very like they want to set up a precast plant. So we are under consultant, and also 1 client from Chennai. They also looking to have a precast factory in Chennai. So these are some of the people whom we are in touch for precast plant setup, and we are giving consulting services. Yeah. So we are right now just an example how we are dealing with these people, what kind of consulting services we are giving. We are having a project in Ranchi. It's like 500 residential buildings, and each of them is 1,000 square feet. So roughly 5 lakh square feet built up area for them. The this project actually started during this COVID scenario, and it is very difficult to get a labor nowadays. You can get computer operator in 15,000 rupees per month, but you cannot get labor in that same amount. And so they understand the problem, and then we suggest to go ahead with the precast construction. So we did initial feasibility study. We did a concept design for this project, and we found that uh, in the initial layout that it was not precast friendly. We helped them to make the layout with precast friendly, and with just minor changes, they are able to get 12% more carpet area in the same cost basically. So with the basic framing details, we understood that hollow core slabs are not like very much going to be favorable in this project. So we understood, and we suggested to go for a half slab, load bearing walls, and precast stairs in this project. And then we help them as a like a vendor selection and other things. So they set up a precast plant at the site with an investment of lesser than 2 crore rupees. And in this, when we are talking 2 crore rupees, like there is no shed. Basically, it's like open precast plant, and mostly like site-based plant are open. So here you can see example of one of their EWS housing scheme from the same project. So here, like on the left, you can see a typical EWS housing or typical conventional layout of any architectural layout of any building. There you can see there are a lot of joints, a lot of load-bearing walls, and very small then openings and all these things. But we did a smart layout in this project, and we could see now we make a square building, and there are, you can see yourself that it looks like very like bigger rooms and other things. So if in the comparison, if you see earlier it was 24 square meter, like this is one of the EWS from this project, and then we made 28 square meter out of this. So this is very much essential that you should make a layout which suit your precast technology. So we come about this project. The project is G+4 residential, the total 500 units, and 1 and 2 BHK. Total built up area is 5 lakh square feet. And when we have slab 5 lakh square feet, then usually load bearing walls are 10 lakh square feet. So, and they decided that partition wall be in a brick. So total they want to make 15 lakh square feet in a precast. These are different type of precast elements: load bearing walls, reinforced room size slabs, stairs, and in partition they are going for brick. Uh, when we decided to go with the precast, so they had tilting tables. So on the same tilting table, one can make a room size slab and load bearing walls. So they chose that they should have a 4 by 12 meter of tilting table, and usually with the 60% of efficiency, one table can produce 28 square meter every day. So to make a 15 lakh square feet in 300 working days, they had a requirement of 16 table production every day. And since we cannot make 16 table every day, we cannot be sure. So they have as of now 23 tables in their factory, and they are making 16 tables. They will be making 16 tables production every day. One staircase mold can give you 2 flights every day. So one staircase mold is sufficient for them. So they will be making this kind of a open site-based plant where there is no shed, and there will be a batching mixing plant at the site and one quality lab. Quality lab and batching mixing plant are key for good quality and good strength. So one should have these things in-house rather than depending on external batching mixing plant or concrete. We help them to get the activity list or schedule of this project. So from mobilization to the site to the project handover, we found that with this kind of setup, they can make 5 lakh square feet in 12 months. So they require 3 months prior production and 3 months after production, because there are finishing and a lot of other activities. So total projects time is 18 months, out of which 12 months they will be taking for the production. We also help them to make an organization chart for the site, and also we have deputed key person at the site for the production, erection, and quality. So we can help for all these things. We have also implemented our software. With the software, you can really track and monitor each and every activity at the site. And the good thing is it's mobile app. So with the mobile app, if supervisor has done some activity, immediately if the same mobile app is using, MD is using the same mobile app, he will get notification that X number of walls are produced, Y number of slabs are erected, and if there is any damage, so they can easily. So it's cloud-based software, and all the stakeholder get the real-time information. So a very small video of this software. So we make a model, 3D model with the help of the software, and then you can make your initial planning. With the mobile app, everybody will get these kind of color coding, and then you can make you can track the status, you can follow up the production with these number of graphs, what is the activities going on, how many is planned, how many is we are doing exactly. With the model, you can choose all your precast element, and then smartly with your production sequence or your erection sequence, you can plan your tables, you can plan your production. So here you can see all these in a 3D also, and that is how you optimize your precast activities production. You can also make a stack. You can track all the elements. We have a RFID on these precast element. You can understand where is the precast element, and then you can plan your transportation also with a like increasing cost of diesel. So it is give you very efficient model, how many numbers of tables, how many on each truck. Then this is a like mobile app. Here you can get all the activity. You just need to screen, you can scan the barcode, you get all the information about the precast element, where it is stored, where it is if then very good thing is if there is any damage, so one can easily update if there is any damage or anything. When here you can see a different kind of color code, you will get a different kind of reports also. Here you can see the damage precast element, so one can assign the duty or what is the cost, who is responsible for it. So yeah, here with this model you can easily understand what is going on at the site. So somebody who is sitting at the site can update, and the information is visible to all the decision makers at the same time. So now our services for this project was, we did initial feasibility study, we did concept design study, structural design right now is under process. We help them to choose the right vendor in terms of techno-commercial. We are in the process to set their site-based factory. We have deputed our people at their site. We will be deputing basically. We have already shared key CV of key resources. Then we are doing a BIM for them. With the help of the software, we are doing factory automation and value engineering. So this, in this project, we are very much involved, and we can provide each of them or any of them services for your precast projects also. So now over to my colleague, Mr. Paul Tate.
Good afternoon, India. How are you doing? I'm Paul Tate. I'm based in the UK. Thank you very much, Sandeep, for that great presentation there and introduction to some of the projects in India. It's come a long way. I've just been asked to speak to give a few insights into some of the precast projects and I've been involved in over the last few years, and just give you my impressions on success measures for it. So I'll just run through a few things. So I've been working now for StruSoft for the last 3 years, and I'm responsible for both our software and services from StruEngineers into the UK and Ireland. 15 years prior to that, I was working for a UK mechanical engineering company, and we specialised in hollow core slab technologies and pre-stressed concrete technologies. So I've been very fortunate to have worked with some brilliant engineers, and I've had some fantastic mentors over the last few years. There's, I'd just like to mention a few quickly. Stephen Carr, Dr. Howard Taylor. If you Google him, there's some brilliant books, and you can see some of his work on precast design. John Durham, Jimmy Roach, David Fox. These guys are still going. But really, without them, I wouldn't be in the position that I am in today. So I'll give you a few insights into some of these. So I've been involved in 25 new precast factories, so greenfield sites. We did many more add-ons and other equipment supplies, but most of those were in developing parts of the world or developing markets for precast. So I was involved in projects in India, Pakistan, quite a few in Saudi Arabia, South Africa, a couple in Botswana, just to name a few. And then the last few years of my tenure there, we did a lot of work in Russia and the Russian Federation. So that's just to give you a flavour of some of the countries where precast is also prevalent. 2 of the projects, interestingly, were site-based precast factories. And really, there has to be the scale, the repetition to warrant the investment in a factory purposely to supply elements into the project. So one was a university, the King Abdullah University of Science and Technology in Jeddah in Saudi Arabia, and huge project. And we were given the order by the contractor to build. It was quite a significant factory, actually. Look, you can see a picture there. It looks more like a permanent factory, but it was a site-based factory, and it was 157,000 square meters of hollow core. And we designed the factory. We ran the factory as well. We put people in to take the responsibility to produce the hollow core. Another project we did with John Durham, who I mentioned earlier, was for a Thermodec project, and this was a new conference center in Botswana, the Innovation Hub. And if you Google it, you can see some details on that. But John Durham sold the Thermodec system to the Chinese contractor, which is an air conditioning system. So we had to put lines of hollow core on the construction site to produce the slabs for that. So that was around 40,000 square meters, and I think it was about 18 months of work. So just a couple of examples, but let's just keep going. So India, yes. So I've been to India quite a few times, and certainly had a few adventures. The company I work for, I suppose we weren't particularly, with hindsight, hindsight's a wonderful thing, but you know, we had some orders, but with hindsight, we weren't particularly successful. A number of reasons. We were too early to the market, and Sandeep showed the graphs in terms of the new factories that started in 2008. We were there, you know, we didn't really have the resources to establish a local presence in India, and we were going back and forth from the UK. We spent too much time educating the market about precast as opposed to being able to sell machinery and equipment. And also the approach we went with was to offer, you know, the European style machinery, I suppose, that more geared for markets with higher labor costs and perhaps a bit more automation. And, you know, perhaps with hindsight, we should have gone for a more scaled back, sort of Indianized, localized machine that was more suited to the needs of the market. So let's keep going. So some of the insights into what makes a successful project. Well, no two project is ever the same, and I've never been to a factory that was ever the same. So you know, the key to it is to tailor the equipment and to tailor the offering to suit the needs of the project or the needs of the local market. And there's so much variety across the world in architecture and design codes and standards. At our company, our most successful period was to go in with a competitive startup package, but design the factory so that it could expand and there's provision to grow easily without disrupting the ongoing production. So that was the key really to the success. So let's keep going. So some of the ingredients to a successful project. There's a picture of me on my last project 3 years ago, and that was in Israel. But really, some of the you know, Sandeep's touched on it in terms of the design and the feasibility, but you know, a real good understanding of the project scope and the capabilities of the customer, setting and managing the expectation on exactly what's going to be provided. And Sandeep also talked about 75% of the planning and design time, but the design time is invariably squeezed, and it's really about the speed that you can, both with equipment and design, but the speed you can mobilize. So, you know, we were trying to build factories on 3 to 4 month lead times. I mean, invariably it took longer with shipping and construction works and site, but it was about the speed that you could deliver the equipment. Being able to manage change, you know, that was winning people over, winning over their hearts and minds, because, you know, this was generally a new way of working. Often, or it might be switching from a wet cast approach to a mechanized process. It might be getting into precast completely new. So, you know, it was really about the proof in the pudding and what was coming out of the machine. So the reliability of the equipment, the quality of the equipment, and more importantly, the quality of the finished product. You're really only as good as your last cast. Like, if, you know, not every project or every commissioning visit was a success to start with, and you were often battling against different raw materials, availability of tools, availability of labor, things outside of your control in terms of cranes and concrete distribution. So, you know, the ability to problem solve, think on your feet. In Israel, there we had an issue with a part, and I had to go myself even and find a local mechanical engineering firm and get the issue resolved in order to keep the production going. So, you know, a real can-do mentality to problem solving. And of course, the team of people, and I mentioned that at the beginning, but, you know, nothing happens without a good team of people, and they need to have the expertise. They need to have that precast experience and know-how, because without it, it's an uphill battle to train and to pass on to the new companies that are getting into precast. A few other simple things I just put there, but humility. you know, we had quite a bit of success, but staying humble is very important. And I put bloody hard work, because it was bloody hard work, some of these projects, and traveling to the far ends of the world a month at a time, and sleepless nights, and, you know, making sure that things were going right. So there's nothing, you know, no real secret to it. It's pretty basic, really, but that kind of approach through the delivery of the factories and the projects, I've now carried on the same approach here with StruSoft and StruEngineers. Okay, we're not delivering equipment as such, but we're delivering the know-how, the software, and the services. And, you know, this is a project I've been involved in over here in Ireland, and you know, it's not dissimilar to what's going on in India. This was initially an in situ concrete project for apartments. The main contractor recognised the merits for going for precast, and they'd already done a hospital project and done some of the columns with precast. But they got involved with us and asked us to support them with the designs of the cores of the building, the solid walls, the columns. So we did that with StruEngineers in India. We provided the overarching design and the standards, you know, the details of the precast. We put in the software and the support for the design and managing the production and the project processes. So, you know, this approach is the same throughout. So let's keep going. What's the next slide we've got, Sandy? Yeah, so just go back one slide. So that just shows you some of the work that we did through StruEngineers in India. You can see the architect's impression of these apartments. There were actually 8 buildings. It's not just one building. We did 8 buildings. So the top left, you can see an IFC model, and that is that was originally done in Impact AutoCAD. You can see in grey the precast elements, the columns and the cores there for the stairs and the lifts, and then the blue is the in situ concrete. And on the right hand side, you can see a 3D representation of a precast wall, and then the shop drawing, and that's through the Impact software. So we detailed, you can see at the bottom here, you know, what we detailed, but it was quite a big project. So 153 master columns, and then 286 wall drawings. So it was about 9 months worth of work for us, StruEngineers. So, you know, quite successful. So you know, seeing India's growth and how it's gone since I started back in 2008, you know, it's come a long way. There's now 60 factories in that period. And just to give you an idea, here in the UK and Ireland, there's also 60 precast factories. But, you know, we're a population of around 70 million people combined. You know, you're 1.3 billion people in India. So what, you know, like you could look more on the output of these factories and a rate per head of population. But it gives you some idea in terms of the potential there in India and what will be coming over the next 10, 30 years. You know, there's going to be something like 2,000 plus factories, I envisage, if you look at the ratio and proportion it. So, you know, now is a good time that the hard work has been done by all the companies and all the equipment suppliers and all the local people, consultants, and everyone involved. There's good momentum, there's good awareness now of precast, and we've seen from the projects that Sandeep showed us that, you know, there's some successful projects. So, you know, the future looks bright for precast in India. So long may it continue. So anyway, that was really just all I wanted to say, just a very quick overview of some of the stuff I've been involved in, and just thank you very much for asking me to come and speak to you today. And if you've got any questions, please feel free to ask, and I'll be delighted to answer them. Okay.
Thank you very much for your presentation, both of you, Sandeep and Paul. So takeaway from this session is like, yeah, there has been a very good journey for India like Paul coming in 2008 in India, and there were like a couple of factories or so. And now we are talking about 60 plus factories. And there could be a lot of demand for precast factories compared to our population in India. So yeah, the journey is quite long, but I think we need right decision makers and right expertise and skills. So there are a lot of opportunities, so to say. Of course, we can help you when you want to set up your production facility, and it is not about like setting up 30 crore plant or 40 crore plant and not having any vision, but we can help you with like 5 million square feet or 10 million square feet, and you need minimum investment on your production facility, and there we can help you with the right vendor management or right technical skills or making the right layouts for your projects which are precast friendly. So thank you all. I hope you really enjoy the session. There has been really good response on this. So we are really open for your questions. You can just put in your questions in the chat box you're seeing in the application there, so that one of us can answer those relevant questions. Sandeep, I think you have access to read those questions, so kindly read if there are any questions coming up. So one question I can see is Sandeep, you mentioned about the open factory. So how about the monsoon period? How did you manage during those monsoon time?
Yeah, that's a very good question. Because we, like, in the very initial stage, we said that there is like open factory. Usually when we are talking about 500 square feet project, so shed and all these things are not viable, because sometimes shed cost is more than what is the equipment cost. And then, so how we manage it usually, in some of the area in North India, the monsoon period is not very much whole days not raining, so one can plan their concreting and other activity based on availability of time. But more or less, I was involved in a project in Bhubaneswar, and Bhubaneswar have a very like heavy rainy season for 3-4 months. So we can plan at least those 3-4 months in our design phase, or let's say in our initial planning activities, so that those three, like our production is not hampered, and somehow those 3 months are also utilized very well. So yes, there is a bottleneck, because we cannot invest 2 crore rupee in a like 1 crore rupee investment of equipment, and then it is not like moving altogether. So we have to deal with, but yes, we have to plan like this only, like there is no other way.
All right. Do you see any questions coming up, Sandeep, on the chat box?
No, sir, there is no other question. So if maybe if somebody has question, they can like mail on our mail IDs. Yesterday, uh, means I already got one mail for some queries, so we'll reply as and when earlier possible. And yes, you have our contact number also and our mail IDs, so one can interact with us with their queries. And if somebody want some consultation, like basic framing details, initial feasibility study, we are open for that also. And thank you for attending the session. That's all from our side. And you can let us know in our LinkedIn process or at our mail if you need some other information. And we also will be putting on this recording session on our YouTube channel, so one can really access after 1 week that recorded session also.
Thank you very much.
Yeah. Okay. Thank you.